Yes, hi. In this video, I'm going to show you how you can make a pattern, something like a waffle. What I'm looking over here is I see something that is more like a checkerboard style, the shape of a cone, and it's a little bit twisted, not like a typical cone. A typical cone, if you create with something like this, they will be like horizontal and vertical, perfectly aligned, and so on. So first of all, this problem is quite easy. You can just twist them, and it's kind of twisted. But the question is, how can you make these edges stick out something like this and make it in a pattern? So I'm just going to show the thought process of different options that you have. And for faster pace, I'm just going to show first on a basic cube, something like that. So whenever I want to convert the edges kind of stick out, there's three main options that you can do. One is you can inset by the amount you want to do. So let's say if I inset it by 5. Um, so basically this creates this inner faces and leaves me only the edges, and it selects the new faces. Then I can do is I can delete these that are still selected, and then I can add thickness to it. So let's say if I add thickness to 3 or -3, and then I end up having a shape like this. Now, this wouldn't work in this case because the add thickness and the inset are not allowed to self-intersect. And if you're dealing with very small faces of a cone, once you have a cone shape on top over here, they will start intersecting. You will be able to do it maybe fraction zero point 0.1 before they start self-intersecting, and this wouldn't be an option. A similar idea is what you can do with, let me show you another shape, more complex shape. If you take, let's say, a sphere, um, you can use it will be the same problem here, that it will be limited to self-intersection. So, but just to show you the concept, I can use one of the bevel tools, either chamfer or fillet. Let's say if I use fillet, and I can remove the fill polygon. So we got only this part, but the same thing, still self-intersecting, and in this case, the protection SelfCAD doesn't allow me to go over self-intersection. So zero point 0.4 is what was the max. Um, if I, for example, would delete, let's say, the top faces, let's say just delete these and delete these, I'll probably get a little bit more than zero point 0.4. It will still be self-intersecting by too much because these are also tiny faces, but still, nevertheless, if I do this, let's say preview, no, it's still zero point 0.4 because I guess they start intersecting here or whatever they start self-intersecting. But nevertheless, this is one option, and then I can do the same thing and add thickness to it, and let's say negative or positive, and then we get a shape like this, and then you can combine them with the cone and so on. But again, these tools are limited mostly because of the self-intersection. Um, the third option is a follow path approach, and follow path has a similar problem with self-intersection, but follow path is actually a very powerful tool. So let me show you just the concept over here as well. So I'm going to create a path that I want should be following. Actually, let's first draw the path that it should be following. So I'm drawing, let's say, a closed path, could be a simple rectangle, and I'm going to be drawing an open path, which could be, let's say, a simple line. And now we're going to be drawing a self-intersecting path, which could be something like this, a line, and then a line that crosses over. Okay, so now I need to create on a different profile an object that I want should be following. Let's say I make a small circle, I type in 1, make a small circle. The way follow path works is that you first have to select the base object that should be used to extrude and follow along these paths. Then I select the other one. Now it will allow you to select only one object at a time, but each object can have multiple paths. So it could be either merged, like in this case, in one profile, or it could be grouped together, doesn't matter. But if I go now follow path and I use the extrude option, what will happen here is that one is actually too short, so I mean too small, I have to zoom in. But closed paths like this would be closely followed, and they will be completely um, solid and a watertight mesh, meaning it will be no interfaces, no nothing. It knows how to treat them. If you think about open paths, it will create a fill. There's actually an option, fill start, fill first, fill last, or whatever, some setting like this. So you can leave it open, add thickness later, or you can have it fill, so it understands it's an open one. So both of these are not a problem. They work very good, and they can work many at once. I can have like 100 closed paths or 100 open paths, or a combination like this, and it will work. This is why it makes it so powerful. You can do a lot of them. However, self-intersecting paths is where the problem becomes. So if I take this one, it understands the self-intersection and it creates a separate object. One object, then this is a second object, and third and fourth. So it splits the objects at the self-intersection. Looks like I had here oh, on all of them, I had a bevel setting. So let me just undo this for a second. I'll just undo all of this. Oops, undo this. Just make this bigger a little bit. Instead of this size, let's make it to 5. Be easier to see. And I'm going to follow it again, this object, but I'm going to, somehow it remembers my previous settings. I had somehow a taper over here. You see the taper? That's why you got this end edges like this. So I'll remove the taper and then I'll let it extrude over here. And you can see over here that at the point of this intersection, okay, let's finalize it so you can see it, it creates separate objects. So this is an object by itself. I can remove it and so on. In this case, it looks okay. You can still see some small hole over here. It looks okay, but this is obviously not manifold. You can use like magic fix. You can group them together and then use magic fix, or sometimes Boolean will work. But in the case of a cone, even Boolean wouldn't help. But even if it would help, it will end up making like extremely a lot of too many objects. So let me just show you here is I'll keep this object that it should be following and then delete everything else. So if I take a basic cone here itself, a basic cone, I'm going to show you. So if I'll have, let's say 24 by 24, if you think about it, will create a separate object for each of these faces. We'll end up having a total of about 2,500 faces, which will take a long time. I actually tried that. I copied all of these edges, just simply selected edges, copied all, select all and copy it. And I ended up about 2,500 objects, which took me about 2 minutes maybe to complete just the follow path. And then I grouped them together. The group itself took about 2 minutes. And then I used magic fix in all of them, which took about 2 minutes. And still you had some holes. So I want to show you how this will look like. Oops, not this one. This one, make it to 1, and just show the problem that you will have over here. So I'm going to select, I'm doing it less so it will take faster, wouldn't have to wait. So I go, what is it, edge selection, and I go select all over here in edit mode. Select all, and I make a copy. Okay, so now if I take this, let's just isolate this, I have this, and now I'm going to select the path that should be following, and then this path, and I do follow path over here, and I extrude that. So here you can see that we get these gaps over here. So it creates like separate objects, and it creates these gaps over here, so which is problematic. And again, we'll also create a lot of objects, but also all these gaps. And even if you use magic fix, it may close it a little bit, but there will still be some artifacts. But here it becomes even more problematic. You see over here, all of these intersections over here. This is 2 intersections just at the end, just the pointers, and the Boolean tool will have a problem with this usually. And Magic Fix will fix it, but it will still leave all of these stuff over here that is not, that doesn't look good. So there's a few options we can do that. We can start with a cylinder and create all of these separately, and then later skew them in separately. But the easiest way would be actually, yes, to start with a kind of a cylinder. So if you start the cylinder, let's say, and I delete the top and bottom faces, so I'm left only with this, and then I'm going to ring select only these edges separately, so I get them flowing in a simple direction. So not loop select, ring select actually in this case. So I'm going to ring select this and make a copy of it. So I have now only these parts, and I'm going to select again the object, and I'm going to loop select the top or bottom of edges. So loop select this and make a copy of this. And now I can use copy offset to add these things, and I think it's minus 4.17. I looked it up before the measurements, and I make let's say 24 copies, I think. So if I do something like this, and now let's group them together. I can group them together because there's no intersection, so they wouldn't make an issue. So I have now 2 separate objects, and then I will take my base object. So I can delete this cylinder, no longer need the cylinder. Um, I still need to add, if I wanted to twist, I know this object, if you isolate this, you see this object actually doesn't have any vertices in the middle, so I can't really twist them. So I'm going to add resolution to this one. These profiles, resolution working profiles as well. So I'm adding resolutions to this so I can nicely twist it. And I'm going to select these objects together, twist them together just to make sure I have no problem misaligning them. And I'm going to twist them, kind of create something that looks like this. And now let's take, okay, delete it, looks like the small object to follow. So I'm going to create a new drawing for my object to follow. Let's use a circle, type in one small circle. And I'm going to follow each one separately. So I'm going to follow this group first, and I use follow path and extrude along the path. So I get these parts. You can see now they're all stitched together nicely. There's no issues. So I still have many objects, but not that many, just like 24 objects instead of a few thousand objects. And I group them together. Again, I can group them because there's no self-intersection, it's not a problem. And now I take this profile again that I want to follow, and I follow this profile, the other edges. And I use the follow path, and I extrude, and we got this. And again, I group them together. Okay, so now once I have these two objects, I can basically use a union. They intersect properly, so union should be no problem. They're all manifold objects, so I can just group them together with union. It's a group. If you have groups, it processes like each object separately, so that's why it takes a little longer, but it's not too bad. And now I can add a cone, a minimum cone. I don't need all of these settings, yeah? I guess it's a minimum cone. And I'm going to make sure that I can skew this object on top of the cone. So I'm selecting this object, and I'm going to skew it, taper it basically, to position it on top of the cone, make sure it intersects without intersection, self-intersection obviously. And yeah, so this also I have to make sure over here, so it intersects like this, but it shouldn't be self-intersecting. So over here it looks like I'll have to play with the cone itself also a little bit just to make it fit. So I can skew the cone, I guess, because this starts intersecting over here. Unless I delete one piece, I can delete the top and then skew it more. But otherwise I can also taper the cone to make it fit into this. And something like this. Oh, I have selected the I've selected the groups the edges, which makes it look strange. Instead of working this, I work with the edges. Let me delete the edges. No longer need the edges. Just delete the edges and just take the cone itself and taper the cone to fit into this piece over here. Oh, the cone has no details. You see, the cone has no detail. I have to add resolution. Otherwise, I cannot taper the cone because there's nothing to bend. So I have to add resolution to it. I don't need that much resolution. I can add something like this. Maybe yes, let's make it tight. And let's taper it inside into this so they start intersecting. And again, yeah, I'll have to probably have to cut one piece on top, but okay, instead of playing here, it will take too much time, but you get the point what could be done. Over here I want to show one other thing that I will color it first, doesn't matter which color, but I'll give it one color, and then I'll use a boolean to combine them together, and I'll show you in a minute why the color was helpful. So once I combine them together, we should have this, has a lot of faces, 147,000 faces already, so union can take a minute. I can probably use the simplify tool to reduce the count, but nevertheless, this is done. So we have a total of what? Oh, 223,000 faces. So actually, yes, it's quite detailed. But once I added the color, you can now go to material selection and select each piece separately. So let's say if I want to color just the cone, this allows me now to color just pieces separately, and I can select now, because they keep colors, they assign a different material for each one. So once I select material, I can just select each material separately, and it allows me to color it, and then basically I can get these shapes. I will use a simplify tool, which probably will remove the colors. I think the simplify does not keep the colors. So if you wanted to simplify, you have to do it before the boolean, before coloring. So um, yeah, you have to simplify each one separately so it will work. Otherwise, you will lose the details. You will lose the colors because simplify rebuilds the object. But nevertheless, this is one way how you can get it done. Um, so this is basically a follow path tool. Now I want to show another way, which is just for the purpose of showing all different possibilities. Each one can be used for different technique, obviously. So I'm going to use, actually let's start with a cone just to get the idea. I'll get with a cone and add some segments to it, and let's add 24 segments, just make it the way it should look at the end. And what I'm going to do now here is that I'm going to copy, go to face selection, and let's loop select a set of faces. So I'm going to select my faces in one direction, and I'm copying the faces themselves. And then I'm going to add thickness to these faces. Okay, let's say 3, doesn't matter. And now I'm going to round this to give it kind of a roundness instead of this. So I'm going to go to round objects, and I'm going to round them all the way. So this basically rounded them, but it added a lot of faces. You have like 262,000 faces because I did the max 5, and this is quite a lot. It looks very smooth, but it's quite a lot. So I'm going to use the simplify tool, and probably even more than once, just to make sure we don't have such an overly complicated object. So we are simplifying. You can also take, yeah, when you have so many objects, things can take a minute. That's just the nature how it works. On downloadable version, probably it's a little bit faster. I'm using the online version. Nevertheless, we're down to 52,000 faces. I can probably simplify it even more, again by 5. So we bring it down to much less, just 5,000 faces. And now we're going to use the copy offset pivot option. So now we're going to make, let's say, 10 copies, depending how many copies you want to make. And I'm getting all of these faces over here. And I'm going to, let's say if they don't intersect, they don't self-intersect, I can just group them together again. The benefit is that they always, SelfCAD keeps selected what you work last, so it makes it easy to just click Command G, and I don't have to make any selection, and they're all grouped. Now I'm going to do the same idea. Let's hide this away for a second. And I'm going to take this shape and select again pieces over here, a loop in the other direction. So I'm going to select this loop, and I'm going to copy it and add thickness to it. Again, the same idea. I'll do the same idea around. I could technically use less round than 5 and then simplify, but I found it that the round object makes very round. The simplify keeps the shape mostly intact. So you'll get a better results by first rounding them with high resolution and then simplifying it a lot, because simplify tool is really an incredible tool that unless you aggressively simplify it, it'll lose details, but otherwise you barely see a detail. Look, it's still quite smooth, and that's what this tool is about. So you kind of can get a much better results if you first round it by max and then simplify it. But now what I'm going to do here is same thing with the copy offset. Unfortunately, I don't know the math now. I have to calculate how much I have to scale it each one. So I'm just going to make a copy and then skew it again. But you can basically, let's see, oh, no, let's move it up by 10, make just 10 copies, something like that. And I'm going to skew this again. I can add a method to the copy offset to scale it, but I didn't calculate this how it should be. But I'm going to group them together, and then I'm going to skew them and taper them basically into the position that I need it to be, something like this. I think I'll probably need to delete the top piece in any case. If you see this piece, are they self-intersecting? They should be self-intersecting. Maybe I made it a little bit too much. And then I'll take all of these 3 together basically, and I union them together, and you kind of get this shape. But yeah, you have to clean it up over here, make sure I can union them. I'm not sure they self-intersect, so I may have some issue here with union or leaving some gaps, but I can be more careful. It will take a little bit more time to clean it up, but nevertheless, this is just another way to do it. Just to show you another tip here, I'm going to actually cut this off using the cut with planes. So I'm going to use the, it may take a while, I have here 118,000 faces, but still should be okay, not too long. And I'm going to use the option over here to split the object and to fill the cuts. So basically what will happen here is that we'll kind of get a separate object on top that will be clipped off, and then I can just delete that piece. So I can basically just take this object and delete them, and now we have an object like this that is basically looks like flat over here. And yeah, so that's basically it. So yeah, again, I'm sorry it took so long this video, but this should give you some ideas to play with. Between all of them, you can create almost any pattern. Okay, let me know if this was helpful, and thanks for watching. Let me know if you want me to show anything else. Have a great day, bye.